Good morning, students. We shall see what is mechanics of a particle. We shall see the definition. The position of a particle P at any time t is specified by the position vector r, which is given in the diagram, and the position vector r is given by r is equal to x of t into I plus y of t into j plus z of t into k, where x, y, z are the functions of t, where here x of t is a function of t, y of t is a function of t, and z of t is a function of t. The velocity vector v of the particle is defined by dr by dt, that is the rate of change of the vector r with respect to the time t, and the acceleration vector r of a particle is defined by dv by dt, that is nothing but d square r by dt square. So we shall denote it by a. So vector a is equal to dv by dt, which is equal to d square r by dt square. Now we shall define what is the linear momentum. And the linear momentum vector p of a particle is defined by vector p is equal to m into v, where v is the velocity and m is the mass of the particle. The total force exerted on the particle is defined by force is equal to mass into the acceleration, where a is the acceleration. Newton's second law states that there exists a frame of reference in which the motion of a particle is described by the differential equation F is equal to dp by dt. That is, F is equal to m into, that is the derivative of mass into the velocity vector, that is d by dt of m into v. If the mass m is a constant, then F is equal to m into dv by dt is m into d square r by dt square. The equation of motion is a differential equation of second order. That is, F does not depend on higher order derivatives, and the reference frame in which F is equal to dp by dt is valid is called an inertial or Galilean system. Now we shall see what is the conservation theorem. Here the conservation theorem means that is the constant, the function will become a constant. So that is given by conservation theorem for linear momentum of a particle. If the total force is 0, then the linear momentum is conserved. That is the statement. Now we know that the force can be given by dp by dt, and here the statement of the theorem is the total force is 0. So we have to consider the force as 0. Then what is the force F? F is equal to dp by dt. So F is equal to 0 implies dp by dt is equal to 0. That implies this p is a constant. That is nothing but the linear momentum is a constant. So we say that if the total force is 0, then the linear momentum is conserved. Now we shall see what is the angular momentum. That's the definition. The definition of angular momentum is the angular momentum of a particle P about the origin O is defined by r cross P, where OP is the position vector, which is denoted by vector r, and the vector P is a linear momentum, and it is denoted by capital L, that is vector L. Then next definition, the definition of the moment of force or torque. If F is a force acting on a particle P, then the moment of force or the torque is defined as N is equal to R cross A. That is the cross product of the position vector and the force that is given by N, which is the moment of force or the torque. Now we shall see what is the conservation theorem for angular momentum. This is only for a particle we are considering. So you have to consider only one particle, and the statement is, if the total torque N is 0, then the angular momentum L is conserved. So we know that N is equal to R cross F. That's by the definition of N. N is equal to R cross F, which is given by R cross. We know F is d by dt of mv. That is equal to R cross, where mv is nothing but P. So that is given by R cross P. So L is equal here. You consider L, where L is equal to R cross P, and if you find out the derivative of L, then d by dt of R cross P is given by dr by dt cross P plus R cross dP by dt, and that is given by dr by dt cross mv plus R cross dP by dt. So the dr by dt, here the rate of change of the position vector with respect to time is nothing but the velocity, which is the product of the velocity and the m into v plus R cross dP by dt, and here v cross mv is nothing but 0 because it is the cross product of the same vector. So that becomes 0 plus R cross dP by dt. We know that R cross dP by dt is nothing but n. So this gives you n. If n is equal to 0, then dl by dt is equal to 0. So L is a constant. And the next definition is kinetic energy. The definition of the kinetic energy is, and we know that is, we learned that in the physics that kinetic energy of the particle is defined by half into m into v square, where v is the velocity of the particle, and the work done is given by integral from 1 to 2 f dot dr, where the number 1 and 2 are the numbers denoting the possible positions of the particle, that is from 1 to 2.